Hello ladies and gentlemen, and welcome back. This is Algebra 1 Section 1.4 for Prospect Charter School. Today we're going to be going over a new concept, which is kind of a bit more like arithmetic than a new algebra concept, called powers of exponents. Now these are not the kind of powers that you read about in comic books. These are about mathematical powers and mathematical exponents. So what are powers and exponents? Well, first we gotta get a baseline, and then we can go and look at what things are. So for an example, let's say that we have 3 raised to the 4th power. Now each part of this has a name. The 3 part is called the base. Now the base of the exponent is the number that is being multiplied by itself so many times. So the number that is being multiplied by itself. And then we have the exponent, or the power. In this case, it's the 4. So the exponent or the power, so let's write that down, exponent, which is also often called the power. This tells us how many times the base multiplies itself. Base multiplies itself. So for an example, if we're looking at 3 raised to the 4th power, this would be equivalent to 3 times 3 times 3 times 3. Note how many 3's there are. We have 1, 2, 3, 4 3's, which is the exact same thing as our exponent. So because we take a number and we multiply it by itself that many times, we call it a power. So in this case, this would be the 4th power because we have it multiplied by itself 4 times. And if you're curious as to what the arithmetic is, a cool trick is to use numbers that we know and can multiply easily. For an example, what's 3 times 3? Well, 3 times 3 is really 9. And then this 3 times 3 is also 9. And we know what 9 times 9 is. That gives us 81. So powers and exponents are a powerful trick, pun intended, to be able to get through some of the problems that we come across in life. For an example, let's say that we have a biological experiment going on with bacteria. And when we start out, we have 1 bacteria. And that bacteria doubles every 5 minutes. So every 5 minutes, the number of bacteria in our petri dish doubles. So the question becomes, how many bacteria do we have after 30 minutes? Alright, well, to do this, we gotta have a little bit of a strategy going on. We know that every 5 minutes, it doubles in size. So what number do we multiply by to double something? If you're thinking the number 2, you would be correct. So our plan would be to take 2 and raise it to a power. Now we don't know what that power is just yet, but we do know that every 5 minutes we are doubling how many we have. Now the next question is, how many did we start with? Well, we started with 1. So what we would have is 1 times 2 raised to an unknown power. The 1 represents how many we started with, the 2 represents that we're doubling it, and the power of x tells us how many times we've doubled it. So then the next question becomes, well, how many times do we double it? Well, it says 30 minutes. So would it be 30 times? Well, no, because it isn't every minute, it's every 5 minutes that they double. So how many doubles do we have in 30 minutes if we double every 5 minutes? Well, to do that, we got to do a little bit of arithmetic. We say, okay, we have 30 minutes, and then we have to cut it into sets of 5 minutes each. So we would take 30 minutes divided by 5 minutes per doubling, and that would give us 6. So the power that we're going to bring this to is to the 6th power. That means that we will have 1 times 2 to the 6th power, and that should be how many bacteria we have in our petri dish at the end. Now, to do 2 to the 6th power, that's actually kind of difficult to do in your head, but there is a trick to it. One of the games that I used to play was how far can you double? How many times can you multiply by 2? And so this is a cool trick, and what we can do is we can just say, okay, well, what's 2 times 2? Well, that's 4. And then 2 times 2 again, that's another 4. And then 2 times 2 again, that would give us another 4. You'll note this is 2, 4, 6 of them, right? Now I've reduced it to 1, 2, 3 of them. Now what's 4 times 4 again? Well, that'll be 16. 16 times 4 is hard to do in the head. So what I do is I turn this into 32 times 2, which gives me 64, and then 64 times 2, which gives me 128. So the cool trick on this one is that when we double it, sometimes it's good to make them into big numbers and then multiply them together, and sometimes it's better just to multiply things by the thing that we're working with. It's really a matter of choice, a matter of preference. If you prefer trying to do large numbers, feel free to do large numbers. If you don't like doing large numbers, then stick with the small ones. There's nothing wrong with that. So another question is, what happens when you have negative numbers that are being raised to an exponent? So let's go ahead and do our little page break, continue with our t-chart. And let's look at the number negative and then 2 to the 3rd power. Now when we're looking at this, I did this kind of on purpose. Notice that the negative is really far away from our power, our 2 to the 3rd power. What this means is that what we're really doing is multiplication after exponents. If you remember your order of operations, the old version was PEMDAS. Please excuse my dear Aunt Sally. But I much prefer GEMA, G-E-M-A, because it's a lot more specific. Division and multiplication are the same thing. Addition and subtraction are the same thing. So we just have multiplication and addition. Then we have exponents, which are identical in both of them. But in PEMDAS, you have just parentheses. Well, just parentheses isn't everything. There's so much more out there. There are roots, there are powers, there are absolute values, there are curly brackets, square brackets, etc., etc. And so what I call them is I get rid of the parentheses only thing because I'm not discriminatory, and I go with grouping symbols. So I have grouping symbols, and then exponents, and then multiplication, and then addition. And what this does for me is, 1, it makes it really short, 2, it's a total gem, and 3, as a bonus, it's Canadian, so it's gem-A. And if you have a really bad accent, you would say something like gem-A, and then you'd have a Forrest Gump reference, and who doesn't like those? So let's go ahead and take a look at this. When we're doing our order of operations, we want to make sure that we do our exponents and grouping symbols first. So, do we see any grouping symbols? Nope. Okay, so grouping symbols are gone. We don't have to worry about them. What about exponents? Okay, we do the exponents first. Now note that the 2 to the 3rd is over to the side, and then that negative is out front. Negatives you can always think of as multiplication, multiplying it by -1. So I take 2 to the 3rd, which would be 2, 4, 8, and then I have a -1 times 8. And what's -1 times 8? Well, that would be -8, and we would be done. Now, what would happen if I used a grouping symbol? For an example, what would happen if I had -2 raised to the third power? Well, then we have our grouping symbols, so we have to do our grouping symbol portion first. And what is our grouping symbol? Our grouping symbol is that multiplication. So we're not going to be raising 2 to the third and then multiply it by -1. We're taking -2 raised to the third. That means we would have -2 times -2 times -2, which, hey, look at that. It brings us back to the same place, which is a little weird, or is it? Well, let's try an experiment. Let's see what happens if we bring it up to an even number. Let's try -3 to the fourth versus -3 quantity raised to the fourth. So, once again, we do our order of operations. On the first one, the negative is done second, so this would be -3 to the fourth. So we do 3 to the fourth. We did that previously. That was 81. So we'd have negative times 81, which gives us -81. Now on the other side, we have -3 to the fourth, which means that we have -3 times -3 times -3 times -3. Now we're going to do the same thing as we did before. We're going to group them up, and we're going to say -3 times -3. What is -3 times -3? Well, a negative times a negative is a positive, so we have a +9. And then another -3 times another -3, well, a negative times a negative is a positive. And +9 times +9 is positive 81. Note the difference. It's a very small difference, unless, of course, you're dealing with money, because who wants to be paid -$81 to their bank account when they should be paid $81 to their bank account? I don't know about you guys, but I would much rather have positive $81 in my account. So when we're doing these, we have to keep in mind the order of operations. If we see a negative number raised to an odd exponent, it doesn't matter. They're going to be negative anyway. But if we have a negative number raised to an even exponent, we have to be worried about the order of operations. Because if it's the negative number being raised to the even power, this would give you a positive output. But if we have a negative and then a number being raised to an even exponent, that would be a negative. So you always have to be careful about your grouping symbols. Okay. And I do believe that is everything for this section. If you would like another example, feel free to ask for one in class. In the meantime, we should probably focus on our assignment. So our assignment for today will be section 1.4, which will be on page 29, and it will be numbers 1 through 1,000,000 all. Okay, yes, I was joking. I'm not that mean. All right, let's take a look at them in more detail. Let's look at numbers 3, 5, 9, 13, and then we're going to go with 15, 17, 21, 23, 27, and because I really like word problems, we're definitely going to do number 29. And then I think the rest is just review from other things. Nope, there's more cool stuff on the next page. Haha, don't you love cool stuff like number 39? That one looks awesome. Number 41 looks awesome. 45 looks excellent. That will give you an idea of what happens when you have fractions. Then we'll have 51, 53, then 55, 57. I know this looks like a lot, but believe it or not, this is like super easy stuff, so it won't be much. If it wasn't super easy stuff, then I would only give you a few. So in my class, if you see only 3 problems on the board, you know they're going to be really, really hard. But if you see like 20 in this case, you know they're all going to be really easy and it's going to be a super fast homework assignment. All right, so there you are. Good luck and have fun.